right? You have 7 objects, 5 are missing. So what will this become? N factorial divided by n minus r factorial. Like how this was 12 factorial divided by
12 minus.
Now, does NPR make sense to you?
Yes, sir.
This is what is called NPR.
Sir,
NPR is nothing. Yeah, sorry, go ahead.
P means what, sir? What do you mean by P there?
Permutation. This is permutation. You're arranging them.
Okay.
Where order matters. So NPR means permutation, NCR means combination.
Okay.
Right. So basically, what is NPR? N into n minus 1 so on till n minus r plus 1. This will be n minus r plus 1, na? Last one. This is 12 so on till 12 minus 7 plus 1. That is 6. Stops with 6. And then this starts with 12 minus 7. So n into n minus 1 so on till n minus r plus 1 is NPR. All you're doing is you're multiplying all the numbers from n till n minus r. N minus r not counted. Okay. Why are you multiplying them? Because they are the
missing terms.
Choices for each place. If you did not 12 into 11 into 10 into 9 into 8 into 7 into 6. Why? First place 12 choices. Second place 11 choices. Third place 10. Like that, 7th place 6 choices. You're multiplying all these numbers because those are the choices for each place.
Okay.
Now let's do a simple problem. Let us say I give you ABC. Okay, ABCD. You have to choose any 3. If I give you 3 places, in how many ways can you fill it?
4,
3, 2. Right. Now, but each of the ABC, if you chose ABC, each of the ABC, in how many avatars will it come? These 3 in how many avatars will come? 3 into 1. So means each ABC is counted in 3 different ways, na?
Yeah.
So if I say that you have to choose 3 people in a team, so will ABC team and ACB team be same or will they be different? Or BAC, BCA, are these 4 teams same or different?
It should be the same.
All 6 teams should be same, no?
Yeah.
Means what? Each team is counted 6 times. Each team is counted 6 times. So if I get 60 items, how many teams are there?
10.
Right? So I have 4 into 3, 12, 24 items here. But each team is counted 6 times. So how many teams do I have?
24 into 6, 140. 140. It's a divided by 4.
I have 24 items. What do you mean by 24 items? See, Akansha. There is one team which is ABC. You leave out a D, that is one team. You leave out an A, B, C, D. You leave out a B,
C, A, C.
You leave out C,
A, B, D.
A, B, D. Now this ABC in how many ways is it counted? ABC, ACB, BAC, BCA, and CAB, CBA. 6 items. This BCD in how many ways is it counted? BCD, BDC, DBC, DCB, CBD, sorry, C ho gaya na? DBC, DCB. It's counted 6 ways.
Yes, sir.
And this ACD, ACD, ADC, tell me then. CAD,
CDA,
CDA,
DAC,
huh.
DCA.
DCA, na? Now this ABD, ABD, ADB, then
BDA, BAD.
Then BDA,
BAD.
BAD. So how many items are you getting overall? Permutations?
24.
You're getting 24 permutations. But but 6 permutations are basically?
One group, yeah.
So total how many groups do you have? 24?
By 6.
Why by 6?
Because each group has 6 different forms.
So just like that, now let us say I give you 10 items or 10 options. Okay. I give you 10 options. A, B, C, D, E, F, G, H, I, J. I give you 10 options. Okay. Now these 10 options may say, I ask you to pick any 4 people. Now I already know permutations.
Yeah.
So we'll reduce this problem to permutation. Is this a Polier reduction? Unknown problem, I reduce it to known problem. I'll say I'll do team selection later.
Okay.
First, let me do permutation. In how many ways can I write? So in how many ways can I write? If I want 4 things on, in how many ways can I write? For the first entry, first letter, how many choices do I have?
10.
Okay.
9. 8 and 7.
Correct. So these are the number of ways in which I can write. Now, if I take any one team, A, B, C, D, in how many ways can you rewrite this one team?
12.
4 into?
So 4 into 3 into 2 into what's?
Right? These 4 I can rearrange in 24 ways.
Yes.
Just see, you'll have A, B, C, D, then you'll have A, B, D, C, then you'll have A, C, B, D, A, C, D, B, A, D, B, C, then you'll also have A, D, C, B. Only for A you got 6. Like that, if you start with B, another 6. You start with C, another 6. You start with D, another 6. You're getting 24. But itna writing all the time is difficult, right? That's why we see mathematical patterns. So that mathematical patterns avoid the need to write so much and to count so much. It's a smarter way of counting. That's it. Permutation is nothing but a smarter way of counting. So if I have one team, that one team has how many avatars?
24.
24 avatars. But total, how many avatars are you getting here by rewriting everything? 10 into 9 into 8 into 7. Right? Which is nothing but 10 factorial divided by 6 factorial, no? N factorial by n minus r factorial, which is 10 minus 4 factorial. Why is it 10 factorial by 10 minus 4 factorial? It is total factorial divided by missing items factorial. From 10 you took 4. So missing items are 6. So total factorial by missing items factorial. That is how we are seeing the pattern, no?
Yes, sir.
I mean, it is just an interpretation. Interpretation helps us get it intuitively. If I by heart it, I have to by heart it as n factorial by n minus r factorial. But if I see a pattern, I see that I have total 10 factorial and I'm dividing it by missing items. Missing items are from 10 I took 4, so 6 are missing. So if I have 20 items, from A I go on till the end, 20 items, and I'm taking 12 items. So what will the number of permutations be?
It will be 12 factorial by 8 factorial.
No, total how many items do you have?
20. Okay, so
20 into so on. 20 factorial divided by
8 factorial.
Why? 8 are missing items. You took 12. So n factorial by n minus r factorial. N factorial is total number of items. N minus r is missing items. Now these are avatars. Permutations are avatars. How many different ways in which you're seeing. But the actual teams are, each one is getting counted how many times? 4 factorial times, no?
Yeah. Into
10 factorial by 4 factorial, 6 factorial. Let's do a simple problem. Let's say I have 6 things and I have to pick 2 things. I have to pick 3 things, okay? No, let's say I have 7 items. A, B, C, D, E, F, G. And I have to pick any 3 people into the 4 people into the team. In how many ways can I pick for? In how many ways can I write for avatars? Can I write for 4? First one I have choices. 6, 5, 4. Right? This is how I have so many avatars for this. So that is nothing but 7 factorial by missing. From 7 I took 4. So missing are 3. This is your NPR.
Yes, sir.
In how many ways I can write my avatars? But each avatar, one of them, A, B, C, D, in how many ways can I write it, count it?
24 times.
4 factorial, no? 4 into 3 into 2 into 1.
Yes,
so my total teams would be?
7 factorial by 3 factorial into 4 factorial.
Now if I take n and r, I have n items and I have r things. What will be your NPR or number of avatars?
N factorial is n minus r factorial.
Correct. Now this I want to make it into teams. So if I take A, B, C, so on till something R items, in how many ways can I rewrite this? Each team gets counted in how many different ways if there are R people in a team?
R factorial.
R factorial. If there are 3 people, 3 into 2 into 1, 3 factorial. If there are 4 people, 4 into 3 into 2 into 1. If there are 5 people, 5 into 4 into 3 into 2 into 1. It is just like NPR, but R is 0. Sorry, R is N. So it's just N factorial. 0 factorial is defined to be 1.
Yes, sir.
It's like missing items are 0.
Yes, sir.
Missing items are 0, so you're getting N factorial by 0 factorial.
Yes, sir.
So number of each team gets counted R factorial ways. So number of teams will be N factorial by N minus R factorial into
R factorial.
Why are you dividing by R factorial?
Because you team up R like in R.
Yeah. So if I have N items and you have to choose R items, the number of ways you can choose R items is
NCR.
But you see NCR and NCN minus R will be equal. You see why? What is NCR? N factorial by R factorial into N minus R factorial, correct?
Yes, sir.
What is NC N minus R? N factorial divided by N minus R factorial into N minus of N minus R factorial. What is N minus R?
R.
Are they both then same?
Yeah.
Why? If I give you 10 items and you have to choose 4 items, I give you 10 items and you have to choose 6 items. Are they both same?
Yes.
What you rejected, this fellow's rejection is this fellow's selection. This fellow's selection is that fellow's rejection.
Yes, sir.
So that's why mathematically we also observe that NCR is equal to NC.
N minus R.
Now let's fast forward into binomial theorem. If I give you A plus B whole cube, what is A plus B whole cube? A plus B into A plus B into A plus B, right? Now let's say these are 3 baskets. This is basket 1, this is basket 2, and this is basket 3. Each basket has 1 apple and 1 banana. Each basket has 1 apple and 1 banana. Okay. Now, in how many ways can I pick 3 apples? How do I pick 3 apples? I have to pick 1 apple from each basket, right? Do I have any choice? It's only apple, apple, apple. If I want 3 bananas?
You choose 1 from each.
But what if I want 1 apple and 2 bananas? Do I have choices here?
Yeah, for apple you have 3 choices. For banana you have.
No, if I pick an apple, the bananas are fixed, no?
Okay.
If I pick the apple from second basket, where am I picking my bananas from?
Okay, first and third. Okay.
Because you're supposed to pick only 1 from each basket.
Okay.
So either I take apple from first basket and 2 bananas, or I take apple from
second basket and
the 2 bananas come from the other 2 baskets, or I take apple from
third basket and then 1 and 2.
So in how many ways can I choose 1 apple? 3C1, no? From 3 choices, from 3 items, I'm making 1 choice. From 1, 2, 3 baskets, I'm taking 1 apple. Likewise, if you want A square B, what does it mean? From 3 apples, you're choosing
2 apples.
Here you got A cube. A cube means what? From 3 apples, you're choosing
3.
Here, how many apples do you have here?
3.
These are apples. Are these apples?
Banana.
So how many apples did you choose here?
3.
Acha, banana is apple.
No.
So how many apples did you choose here?
0, 0.
Right. So what is happening? You're getting a plus b whole cube. A plus b whole cube. You're able to see it as 3 from 3 baskets. You chose all 3 apples only. Or you can choose 1 apple. So the other 2 will be choice of 1 apple implies the other 2 choices are bananas. Does this make sense?
Yes, sir.
Now let's see a simpler example. Let's see a simpler example. Let's consider a plus b into a plus b. How many baskets do I have here?
2.
Okay, initially I'll choose how many apples? Max, no? Then I'll choose.
1 apple, 1 banana.
Then I'll choose.
1 apple, 1 banana.
1 apple, 1 banana over, no? After that.
2 bananas.
What is 2c? 2 factorial by 2 factorial into 0 factorial. What is 2 factorial by 2 factorial? Cancel. 0 factorial is 1. So that is a square. What is 2c1? 2 factorial by 1 factorial into 1 factorial. No, r factorial n minus r factorial. That is 2ab. What is 2c0? 2 factorial by 0 factorial 2 factorial, which is 1. But you understand the logic? From 2 baskets, I'm choosing 2 apples. From 2 baskets, 1 apple. From 2 baskets, 0 apples. Now let us say I take a plus b whole part 10. Initially, how many apples do I choose from 10 baskets?
10.
So no bananas. Then what do I do?
You choose 1 banana and 9 apples.
9 apples, 1 banana. Correct. Then what do I do?
8 apples. It's
Last?
b square. So we get b square.
Correct. Last?
10.
10c0, b per 10. 0 apples. But it's so painful to write so much. No? So what do we write? This is some I. We see a pattern.
Yeah, it's decreasing.
If this fellow is an I, if this fellow is an I, this fellow is n minus I. This fellow is also I, and this fellow is
n minus I.
So I chose I apples and
n minus I
bananas. And I starts from
10.
Or we'll write ulta. I starts from 0 and goes till
10. Okay.
You can also write a par n minus I, b par I. Both are the same. Because NCI and NCn minus I will be equal. There are 2 different ways of looking at it. So is binomial theorem clear now?
Yes, sir.
Okay. Now, let us say I give you a square plus b whole power 20. I want the coefficient of a power 24. If I want 24 apples, the first item, how many should I take? And second item, how many should I take if I want 24 apples?
24 apples.
So if I take one item of this, how many apples am I getting?
2 apples.
So how many items should I take?
12.
And how many items of this should I take then? I took 12 of these. So how many will I be left with?
8.
So from 12 baskets, I took double apple pair. I can't take only one apple. I can only take a
2 apples.
Apple pair. So I took 12 here and 8 here. So in how many ways can I make this choice?
12
From 20 baskets, I have to choose 12 baskets. No. This is a square plus b is like 20 baskets, right? A square plus b into a square plus b.
Okay, I got it.
So from 20 baskets, you're choosing?
Choosing 12.
So that is 20C12 A square whole power 12 into B.
Yes, sir.
So this will be the A power 24, the coefficient will be A power 24, B power 8, 20C12. You will not get A power 24, you will get A power 24 into B power 8. Now let's see a simpler question. What will be the coefficient of A power 19? What will be the term which will have A power 1947? So how many A's do you choose then? 1947. How many B's will you choose then? 73, no? 2020 minus 1947.
Yeah.
The age of India. India's age is 73, no? Right. Now, so what are you doing? In how many ways can you choose 1947 apples? 2020 C
194. 9.
right?
Yes,
So
sir.
this becomes into 2A whole power 1947 into 3B.
70.
So the coefficient will be A power 1947, B power 73 into 2 power 1947, 3 power 73 into 20C 1947. So if I have PA plus BQ whole power n, if I want A power R into B power n minus R, what will be the coefficient? I have to choose from n baskets, I have to choose R. Then I'll get P power R, Q power.
N minus R.
This will be the coefficient of this term.
Okay. Yes, sir.
This is binomial theorem. So binomial theorem is just a direct application of combinations, no?
Yes, sir.
It's just looking ki how many baskets do I have, how many apples do I take, and how many bananas do I take.
Yes, sir.
From n baskets, if I have to take R apples, the number of ways in which I can do it is
N minus
NC
N
R.
minus.
See, Akansha, if I have 20 baskets and I have to take 8 apples, in how many ways can I take it?
You have 20 basket, you have to take 8 apples. Take it 20 factorial by.
It's just 20C8, no? Choosing 8 from 20.
Yes, sir.
Now let us say you want to make a phone number and I'll give you 7 digits. You want to make a 4-digit phone number. I'll give you 7 different digits and you have to make a 4-digit phone number. In how many ways can you make it? Digits cannot be repeated. Then it will be 7P4.
Yeah.
Because here order matters.
Okay.
But let us say order matters, no?
Yes, sir. Yes, sir.
Because 9742 is not same as 9724.
Yeah.
But let us say I give you 20 oranges and I say that choose any 3 oranges. Will the order matter here?
No, sir.
So if I give you 20 oranges and say choose any 3 oranges, in how many ways can you choose?
20C. 3.
3. You're choosing 3 now.
Yeah.
That's what we noticed, right? See, we said that initially, if I have to arrange them, I'll arrange them in 20p3. Right? But we said each team gets counted how many times? 3 factorial times.
Yeah.
So it is 20p3 by 3 factorial.
Yeah.
So NCR is NPR by R factorial.
Yes, sir.
So NPR is n factorial by n minus R factorial.
Yes, sir.
That you're dividing again by R factorial.
Yeah.
You have only today Dashara, or tomorrow also you have holiday?
So tomorrow also I have one.
Okay, then what I suggest is at 4 o'clock. By the way, you have doubts in matrices also, or only this?
Sir?
You have doubts only in matrices or this also? I mean, only in this, or you have doubts in matrices also? Because I'm taking a class on matrices.
Matrices chapter.